Hey everyone, it's Dave here again. So this mini lecture's on significant figures. One of the best ways to teach significant figures, I think, is by example, but just to get you started, to give you an idea of why we use these sorts of things, I think it should become pretty obvious to you that when you write down a number that's associated with a particular measurement, necessarily there's going to be some error in the measurement that you're making, and it would be to some degree inappropriate, for example, if you used just a common everyday ruler to measure the length of something and then you wrote down the measurement that down to say 20 decimal places, indicating that you could measure things with that degree of accuracy, and clearly you can't. So let's just, with that in mind, let's just progress through the lecture. So, alright, I guess I've made that, well, not particularly that point, but I've made the second point here. Really you're using these significant figures because measuring instruments are only so accurate, and therefore it would be inappropriate for you to use just any number of decimal places. Significant figures are often used in scientific experiments and reporting values, so that people get a bit of an idea on just how accurate those measurements are. There's some notes for you. You can read them at your leisure. I just want to really get into it. Okay, so how do you apply these significant figures? So what you do is, well, there's a number of different ways, but this is the way I like to do it because it's just very, very simple. So to work out how many significant figures a particular number has, you simply write it in scientific notation and then count the number of figures in the coefficient, and that's it. So let me just give you an example here. If I've got a number like 4.5 by 10 to the 3, it's got 2 digits in the coefficient, so therefore it has 2 significant figures. This one here is a more accurate measurement, and it's got 1, 2, 3 digits in the coefficient. So they're 2 different numbers, so to speak, this one indicating a greater degree of accuracy than this one here. As to which one it would be, of course, it would depend on what particular instrument that you're using. So if we had a few other examples of how you could write down numbers expressed to a correct number of significant figures, here's one here. So if we asked you to write 3,456 to 2 significant figures, the first thing I'd do, of course, is write it in scientific notation. So there it is there. And now you look at the number of digits involved in the coefficient. At the moment, of course, there's 1, 2, 3, 4 digits, and we only want 2 digits to indicate the number of significant figures. So what you're going to do is, of course, round it off. The general rule of thumb is, obviously, if it's 5 or above, you round up, and if it's below 5, you round down. So in this case, this number would then be rounded off to 3.5, and here's our coefficient with 2 significant figures in it. You can write things out in everyday notation. There is a convention for counting the number of significant figures in non-scientific notation, and the rules are quite complex. I'm going to show them to you in a minute, and that's why I just prefer writing everything in scientific notation. So for example, this number here is actually written to 2 significant figures. Alright, let's have a look at some others here. If we're writing this number here to 1 significant figure, you can see we convert it to the scientific notation first, and then we round off. In this case, it just becomes 5 by 10 to the minus 3. Now, as I said, these rules are here. You can have a look at them. I'm not particularly concerned about you learning them. You will probably encounter them as an undergraduate, and I guess it's more of a heads up for you that there are other rules that you can apply. The rules that I've given you are perfectly legitimate using scientific notation, but this is, if you like, the rules that you would use if you were using non-scientific notation. Right, and I'm not going to even read through them. You can look at them at your leisure. Okay, so let's look at a few other exercises using significant figures. So for example, this one here, write 370 to one significant figure. What you would do is think, well, okay, this is 3.7 by 10 to the 2, for example. At that point, it would have 2 sig figs in the coefficient. You'd round that off to 4, so it would be 4 by 10 to the 2, and you could write that answer as 400 or 4 by 10 to the 2. I don't really care, but the process would just be simply what I've shown you before. Convert things to scientific notation and then look at the coefficients. And there's some other examples for you. I'm not going to go through them now. Now, that's how you work out the number of significant figures in particular for particular numbers. Often, of course, you're manipulating those numbers by way of particular calculations, and when you think about it, of course, your calculations are either going to be multiplication and division or addition and subtraction. So we've actually got 2 sets of rules that we need to apply depending on whether you're doing one or the other. So we group multiplying and dividing together, and for that you work with significant figures, and the rule is actually quite an easy one, and that is that the answer that you come up with should have the same number of significant figures as the least number of significant figures in your calculation. So if you've got 2 numbers and you're multiplying them together, for example these 2 here, this number here has got 2 significant figures. You can think of that as being 4.2 by 10 to the 0. 10 to the 0 is 1. So in scientific notation it's still got 2 significant figures. This one here has got 3 significant figures, so your answer has to have 2 significant figures. So when we multiply the 2 together, we end up with this number to start with, and at this point it's got 1, 2, 3, 4 significant figures. So, and as I've said here in the original problem, this number here, 4.2, had only 2 sig figs. So therefore the answer can only have 2 sig figs, so you're going to have to round it off, and you can see here that the number that you'd end up with would be 14 or 1.4 by 10 to the 1. It's the same thing, of course. Now, as I said, there's 2 separate rules here. One of them is this sig fig rule, and that deals with multiplication and division. Please make it clear in your mind that when you're dealing with addition and subtraction, you don't use sig figs. I'll say it again, you do not use sig figs in that instance. What you do is just simply use the number of decimal places, which isn't the same thing. So other than that, the rule's kind of pretty similar to the sig fig rule, and that is that you can only be as accurate as the smallest number of decimal places in the original calculation. So here's an example here. We've got 34.5 plus 22.25. Forget sig figs, it's got nothing to do with it. How many decimal places have we got here? Well, we've got a 5 here in the tenths column. Here we've got a 5 here in the hundredths column. But the least number of decimal places in the calculation is in the tenths, so the answer must be in the tenths. So if you do the calculation, there's just a little summary there. Whoops, go back here. If you do the calculation, then your answer is going to have to be to the tenths column.